For most of my electronic models, I want something that will move from side to side, backwards and forwards, go out and then come back in. Something like what this should do. If I switch it on, goes out, waits a little while and then comes back again. I have a button that enables me to operate it, so it goes out, stops and then comes back. What I like to be able to do is to use this just using Lego rather than the electronics. One of the simplest ways to do it using Lego is just to use a chain. If I have a chain here going round, idler gear at this end, driven by the motor at this end, with this carriage on top here, which is just driven by 1/2 of a tread. So I've actually criminally cut off the bottom of the tread so that only the top half connects. If we try it, we need to plug it in as usual. Can we get it the right way around? Let's see. If we press the button, then the motor rotates, rotating the chain then has its link up in between these two, and therefore that goes out and then comes back again. Doesn't have to reverse the motor's always going in the same direction. Don't really like that on the principle of this. Can't see a easy way around it using the chain or Lego. Suppose I could modify the links and put a metal piece on that comes up rather than using this, but it works, and maybe I ought to use it. Works well. Maybe I should have used that. But what I really want to do is to build a mechanical sort of device, a mechanical reversing system. I come across, basically I've got 3 ways that I can reverse a mechanism. First one then is to use an idler gear. In other words, here we have direct connection between input and output, and if I move the input, we can see that the output is actually going in the same direction because I've got this onto another gear. If it was on this gear, it would move. Perhaps I'd be better altering that, so that, and then when I move it across, it moves in the opposite direction, because this one's an idler gear. Another way of doing it then is just to use 2 contrary gears which slide from side to side. Here the right hand gear is in contact with the output, and then when I slide it across, the left hand gear is in contact with the output, so it goes in the opposite direction. That seems the best way to me, and therefore I'll do a separate video on that. And here we have the Lego clutch, I think it is, whereby it moves across from place to place. So at this particular position, it's driving this gear on the right hand side, which is turning my output gear in a clockwise direction. But if I slide it across and keep going in the same direction, then the output gear is now going in an anti-clockwise direction. So yeah, that seems okay, but it's far too difficult to move this on this particular piece of Lego, which has ridges on it, which the centre part has to move over, and it finds it very difficult to move it across. And to get something to actually move that, I can move it of course, but if I want something to move it from the Lego, can't find a way to do it. Maybe there is one, but I can't find it. So if we look at the idea of the idler gear, what sort of things can we come up with? Well, this was one of my early designs. The idea being that you don't have to have end stops on the rack. All that happens is that the motor keeps rotating and its speed is reduced down by a couple of big gears onto this gear here, where we have an arm which is going to move the gear across, like on here. So this arm is connected onto the eccentric and it moves across on its own. So will it work? Well, if we try it, hopefully what we find is, oops, it's gone off the end. If I put it on, it takes it that way, takes it the other way, keeps coming off the end. Maybe if I put it the other way around it would be better, because the problem with this essentially is it moves further in one direction than in the other. Of course, it has the usual problems of Lego, normal Lego, studded Lego, that it falls apart. So yeah, it could work that, but it's very big, very bumbly, got this great big reduction gear on it, which makes it difficult to build and to build into my models. So I've given up on that sort of idea as being too big. Another one which is big again, this uses the idea that we can flip across using these pieces on the rack. They come across, touch this, move it across, and because it's on an elastic band, then it moves across like so. Something was jamming it. When it's got to this end, then this end of the rack comes across and moves that across, and something's gone wrong. Oh, that's too far across. Anyway, so it should, if we can get this to work, no, I can't get it to work, should move across. Try it with power, but I don't think it's going to work because it takes too much power to operate it. That's the wrong way, so we have to get it going the right way. So now it moves across, that's come across, altered the direction, but if I hold it, then sometimes it works, but sometimes it doesn't. So yet another difficult situation where it isn't really working as I'd like it to, and it's far too big anyway. If we could build something smaller, I wondered about something like this, using the this would be an engine. I've made this piece myself. It would be part of the engine block. It's the same as the Lego piece, but once again, nah, not happy with it at all. So let's move on to a different sort of technique of using, and that's to use pins. So what we've got here then is a mechanism that relies on friction. Probably won't work like most of the others. No, wrong way around. Should have sorted that out. Try it that way. Goes across, then it goes back again, and then hopefully it'll go backwards and forwards, because what we're doing is we've got little arms that come out and stop these gears. So in this particular position, this gear is going to this idler gear, and this idler gear then turns the output gear. But when it moves horizontal, then the idler gear isn't involved, and therefore it goes in the opposite direction. To hold it in place then, we just have little arms that come up. I don't know if we can see the one on the inside there, that holds it, and that is operated by this slopey brick here, and that then just allows that arm to be in place until this end hits here. when it removes that arm, and then it moves on to the next arm, which is operated by this mechanism here, and oopsie, and that then stops it. But the problem with this is it depends on friction, and often we don't have enough friction to turn this round, so therefore it doesn't work as I would like. Another one that's similar to that is this particular one here. Now we'll leave that one and look at this one. This one's got a similar sort of idea. It has a stop up here which is operated by this mechanism. So when this is pushed, that lifts this stop up here. This is just a weight so that it flops back down again, where I'm at there. So it flops back down. So this arm here comes up, touches that there, and that then holds it in place until it's moved by this. And after it's moved by that, then it moves round into the position it is now, where it is now held in position by what? By something else, by this other arm here. This little arm here now holds it in this position. So now this is touching the idler gear and not the, well, it's touching the output gear, because this one up at the top here is the idler gear. So yeah, that's another mechanism. If we try it, will it work? Probably not, but we can try. Oh yeah, seems to work okay. You can see how the arm comes, touches here, that lifts up, and then it moves round to the next position, where the next arm down at the bottom holds it in place as it goes backwards and forwards. Seems to work quite well this then, but once again is a bit too big and bumbly. And there what's happened is we've lost the friction. So this is going round but isn't got enough friction to keep it going. So we have to move this across to keep the friction on these pieces so it keeps turning round. So once again, not that good. Finally we've got this one, similar sort of idea, where what we've got is motor, gears here and here. These then are permanently turning, and they turn round and touch against this contrary gear here, which is the one that drives. So when it's driven on this side, it goes in one direction. When it's driven on this side, it goes in the opposite direction. Once again, we've got little levers to stop it. In this case, the little levers are coming out from the side here, and they then stop these pieces. So at the moment, this little rod here is stopping this piece going round, and therefore it keeps it in that direction until that is hit, and that then moves that rod out of the way when this does a half turn and comes round and touches that rod. So let's try it. Will it work, won't it? No, it won't, because I've lost my connector. Put my connector in. Try to use only 2-pin connectors on motors and 3-pin for power. So I need an adapter for my power to my motor. Oopsie. And here, if I move that out of the way, we can see how this flips round, comes round, is touching the peg at this side, and then flips round and touches the peg at the other side, going backwards and forwards, doing exactly what I'd like it to do. It's quite nice, neat, compact, but occasionally has problems like that. because it's designed with studded Lego, and that then tends to come apart with the forces that are being used on it. So yeah, beginning to struggle because it's coming apart. If we press it back together, then hopefully it will keep going. So seems pretty obvious, anything that's built in Lego needs to be built with technical Lego and not studded. So yeah, so those are the models that work based on idler gears, or turning the gear from the opposite side. So bye now, bye.